Hi everyone, my name is Jake Lautensock. I'm a TA for Chem 285 for Dr. Savage's class. This is a review going over naming and go ahead and share my screen. Just so everyone's aware, this is not a comprehensive IUPAC naming review, but rather a focuses on kind of the key points you need to know for Chem 285 here at BYU. So you should have this functional group sheet in front of you as you begin to name. On the back of it, it has instructions, but we'll mostly just look at this priority list here. Okay, I'll go ahead and stop my camera. Okay. So we'll kind of go over what is the key features of naming, and then we'll do a couple practice problems. When it comes to naming, the first thing you want to do is identify your highest priority functional group. That's the first thing you want to do on whatever molecule is given and that you need to name. So we have, if you look at this list up here, you have the list from carboxylic acid all the way down to alkane. That will be the order of priority. So let's say hypothetically you have an alcohol in a molecule and a carboxylic acid. Of course, your carboxylic acid gets the highest priority because it's higher up on the list, and we'll use this as the suffix of our name. Okay. So you identify your highest priority functional group and the suffix that names that highest priority functional group. Next, you will, and this is only sometimes, you want to identify where it is. There's a few caveats here. If you have a carboxylic acid, an ester, an amide, or an aldehyde, these are chain terminating, meaning that it has to be on the one carbon. If it's not on the one carbon, it's not really possible to have that functional group. Okay. And if that's the case, if it's on the one carbon, you can omit the one and just kind of reduce it and get rid of that in the name. Okay. The next thing you want to do is identify the root of the word. And the root is going to be the longest carbon chain. And that's going to be connected to the carbon on the, we'll abbreviate it as highest priority functional group. Okay. An example of when the longest chain wouldn't be, or the longest chain in the molecule wouldn't be the root is like, for example, on an ester, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 carbons. 2, 3, 4, 5, 6, and the other side has 6 carbons. The longest carbon chain that's connected to your highest priority functional group carbon would be 6. Okay, and how do you you kind of tell me the name of or how long it is you'll use the Greek prefixes. So like meth, eth, all the way up to like hex, pent, hept, etc. Okay. Next, you want to identify if there's any double bonds in that longest carbon chain. And you will do that by saying AN or EN. AN indicates no double bonds, and EN indicates that there is a double bond. If it is EN, you have to tell me where that double bond is. For example, that double bond could be coming off the 2 carbon, or it could be coming off of the 3rd carbon here. So you have to just be specific. And the last thing you want to do in your root is you want to identify if it's in a ring or not. This should be pretty obvious. But if we're in a ring, then you need to put cyclo in front of the root. Next, you'll go and move on to your prefixes. I like to say that this is everything else. So if it's not your root, the double bond, ring or not a ring, or the highest priority functional group, it goes into your prefix category. And you name all of those items with the prefix term here. Okay. So let's jump into a few practice problems here. I'll just make up a few molecules. One more thing here. So I'll just throw a few examples. Let's say you have a 1 carbon piece coming off. That would be a methyl group. Meth meaning 1, eel meaning it's an alkane. Another example would be, let's say you have an alcohol coming off of your longest carbon chain. It would be a hydroxy piece. And you need to identify where it's coming off of. So if you have a carbon chain, and there's an alcohol coming off of it, it could be coming off of the 1 carbon, or the 2nd carbon, or the 3rd carbon. So you need to be, you can't show any ambiguity in the name. So you must identify where, or the location of all of your substituents, and substituents means pieces coming off of it. Okay. Lastly, what else goes in here is if there is an ester, then the carbon chain coming off of the oxygen, so this oxygen and the carbon chain coming off of it, will be named as its own word. And we'll look at an example here. So we'll throw an alcohol onto there and a double bond. So the first thing I want to do is we'll follow my rules up here. Is I will identify your highest priority functional group. And I'll change colors here. So my highest priority functional group is a ester. So if you go to your naming sheet here, an ester has the suffix of -08. And what carbon is it on? The 1 carbon. Next, I'm going to identify my longest carbon chain. In this case, it's 4. So my Greek prefix for 4 is but. Next, I want to identify if there's a double bond or not. And in this case, there is. It's coming from the 2 carbon going towards the 3 carbon. So it's going to be a 2-ene. And then we input the highest priority functional group at the end there. So what else do we have? We have an alcohol coming off of the 3 carbon. So that's a 3-hydroxy. We have to label where it is. And I'm showing you that if it's an alcohol, it'll be named hydroxy if it's not the highest priority functional group. So we'll put that out front. And then you would probably say, well, that looks good. I named that molecule. But what we missed is this little carbon chain coming off the ester. That's a little special ester piece that we kind of defined up here. It's a carbon chain coming off of the oxygen, and we will name it on its own as its own word. So what is that? Well, it's 2 carbons long, which is F, And how do we name a carbon chain? YL. And it gets its own word in the front. So we have a space. So the name of this molecule is ethyl space 3-hydroxy-but-2-ene-OH. Let's quickly talk about how we put these words together. So every time you have a number to a letter, you need a dash. And you don't put a space between two different items in a word. And the only time is when it's a special ester where we have a space right here. Okay, let's do another practice problem. Okay, so what I want to do is identify my highest priority functional group. In this case, it is a carboxylic acid. So if we look at our sheet here, carboxylic acid is oleic acid. And like I said before, its carboxylic acids are chain terminating, meaning that, of course, it's going to be on the one carbon there. Next, we are going to find our longest carbon chain that's connected to that carbon. You might ask yourself, well, can I label this as 7 or is 1 7? And it doesn't really matter. Whatever one you label 7, the other one is going to be your substituent. So we'll just label it linearly. 7, or sorry, that's 7, 8. So what's 8? Well, 8 is oct. And let's actually throw in a double bond here. Oct, 4, ene, oleic acid. I guess this is the other time where you'd have a space. Next, we got to label all the pieces coming off of it. We have a 4-hydroxy, or sorry, that's 4-methyl and 7-methyl and 6-hydroxy. This kind of introduces another principle here, is if we have two of the same things, we put them together like this. 4, 7, tell me where both of them are, how many you have of them, 2, di, so it goes di, tri, and so forth. Dimethyl. When you have more than one substituent, like we have here, we have methyl groups and hydroxy groups. How do we order them in the name? Well, we order them alphabetically by the substituent name, not by like the di or tri. So what's this word? Well, H is before M, so it's 6-hydroxy. 4, 7 dimethyl oct 4-ene oleic acid. You might ask, well, what if those methyl groups are on the same carbon? You would still have to tell me where each of the locations are. Okay, well, let's do one more, and then I'll make another video after this one, kind of going over some harder examples. Okay, so here we have a ring, and I'm going to show you and prove to you that your rules are followed the same way that you've identified these ones, and it shouldn't change that it's in a ring. So what's your highest priority functional group? Well, the highest priority functional group is a ketone. What is the suffix of a ketone? Well, it's O-N-E, own, or one. where is it? Well, this is where it becomes a little ambiguous. Your ketone, for example, if you have a molecule like this, it could be here, could be down here. So I guess it's a symmetrical molecule. It becomes important where the ketone is, okay? In a ring, we could start counting really anywhere we want. For example, 1, 2, 3, 4. But what we want to do is we want to give the highest priority functional group the lowest number possible. So since we can kind of start counting wherever, we should give it the number 1. And then we start counting the direction that puts the substituents or the pieces coming off at a low number set. So if we were to count this way, it would be 2, 3, 4, 5, 6. And it would make these 6 and 6 and 5. And it would put the set of numbers higher than if we were to count this way. Okay, you might ask, well, I see the longest carbon chain is 1, 2, 3, 4, 5, 6, 7, leaving the ring. Well, one of the rules we need to follow is once we count within a ring, we're not going to exit the ring, okay? So let's do it. So we identified my highest priority functional group. And then after that, we always identify the longest carbon chain. So it's 1, 2, 3, 4, 5, 6. So 6 is hex. Is there a double bond? Yes, it's on the 2 carbon. And we'll put in our suffix. And this is where it would be appropriate if you want to indicate that it's on the 1 carbon. We still kind of infer the fact that it is because it's in a ring. And lastly, the piece that we have kind of been omitting because it was obvious on the other ones is we need to ask, well, is it or is it not in a ring? And that longest carbon chain is in a ring shaped. So we have to put cyclo in front of it. Okay. Next, we label all of our substituents. So off of the 2 carbon, we have a 1 carbon piece. 1 is meth. And how do we label a carbon chain? Well, YL. And off of the 3 carbon, and you know, we've done hydroxy twice. So let's change that to an amine group. So we have a 3 amino. And that should be everything. So we just order those alphabetically. So we have 3 amino, 2 methyl, cyclohex 2 enone. And that is kind of the fundamentals of naming in Chem 285, following the IUPAC rules. The next video, we will go over a few specific or more challenging examples.